Hi, welcome to C3 Differentiation Part 2. So again, I'm just now going to do a few more simple basic differentiation before I move on to tangents, normals, stationary points. Okay, so 4x minus 6 over 2x minus 1. Okay, this looks quite simple, okay, and it is. U is 4x minus 6, V is 2x minus 1, U dash is 4, V dash is 2. So it's quotient rule, VU. So we get VU dash minus UV dash, so you get 4 lots of 2x minus 1, which is 8x minus 4. And we take away 2 lots of 4x minus 6. So we take away 8x minus 12. So VU dash minus UV dash over V squared, which is 2x minus 1 all squared. So the answer there is minus 4 plus 12, which is 8 over 2x minus 1 squared. Okay, so that's the first one there, quotient rule. Number 2, e to 2x tan x. Now here we have got product rule. Okay, so you get that. Now tan differentiates the sec squared of x. So here, product rule, because I've got two functions each containing the variable. So uv dash plus vu dash, you get e to 2x sec squared x plus 2e to the 2x tan x. So uv dash plus vu dash there. Now if I had to solve that equal to nothing, then what you would do is you would factorise e to the 2x out to get that, and then solve equal to nothing, and that will be a stationary points question. Okay. Now obviously e to 2x can never be nothing because the range of it is always greater than nothing. Okay, so you would basically be solving sec squared x plus 2 tan 2x equals nothing. Now number 3, I'm differentiating x squared times root of 5x minus 1. So u is x squared, v is 5x minus 1 to the half. Common error will be minus a half there. U dash is 2x, v dash is a half. 5x minus 1 to the minus a half. So then you get uv dash plus vu dash. Now as you can see there, I've got something wrong. Very rare. Very unlike me, but I've forgotten to times by 5 at the end. Now that is absolutely essential, guys. So it's 5 over 2, 5x minus 1 to minus half. Then you do uv dash plus vu dash. So you get 5 over 2x squared, 5x minus 1 to the minus half, plus 2x times 5x minus 1 to the half. Okay. Now number 4. There will be a video on questions to do with exponentials and logarithms when you've got one of those dodgy situations, like real life situations, bacteria and things like that. Now here's a question where you might be asked something like that, but differentiate at the end. Now 8 to e to the 5t looks a bit awkward, but as we know, e to the 5t goes to e to the 5t times a fifth. Fifth of 80 is 16. Now do them on your calculator if you've got time, because 80 times a fifth is 16, but some of you will probably put 14 or 18 or something in the spare at the moment. Okay. Now number 5, ln of x squared plus 1 over x squared plus 1. So it's quotient rule yet again. Okay. Now ln of x squared plus 1 is u. Okay, and u dash is basically 2x over x squared plus 1, because we do a differential of a function f dash over f. Now v is x squared plus 1, so v dash is 2x, and when we do the quotient rule now, vu dash minus uv dash, we basically get x squared plus 1 times 2x over x squared plus 1, take uv dash, which is 2x ln x squared plus 1, all over v squared, okay, which is that. But the eagle-eyed of you will have noticed that that and that cancel. Okay. So you get 2x minus 2x ln of x squared plus 1 over x squared plus 1 squared. And I suppose you could factorise the 2x's out. But I personally wouldn't lose any sleep over that unless it's a sure that question. So the rule of thumb is don't break your back to simplify things and end up getting it wrong. Okay, I don't think you'd lose marks really if you simplified wrongly, but it's not worth taking the risk. Now e to the x minus 3 over e to the x minus 2. Okay, now this looks a bit dodgy and I've seen it before in questions. Now just a bit of a tip to start off with. If you weren't doing differentiation, if you were just solving that equal to nothing, you would just basically do top equals nothing, e to the x minus 3 equals nothing, e to the x is 3, x is ln 3. So I'm just trying to remind you of certain basic skills there. Now u is e to the x minus 3, and v equals e to the x minus 2. So u dash is simply e to the x, and v dash is simply e to the x. So when I do quotient, I get vu dash minus uv dash over v squared. So vu dash is e to the x minus 2. Take away uv dash, which is e to the x minus 3, over v squared, which is e to the x minus 2, all squared. Okay. Now that gets, when you multiply out, e to the 2x minus 2e to the x minus e to the 2x plus 3e to the x over e to the x minus 2 all squared, which actually gets me e to the x over e to the x minus 2 all squared. Okay, a couple more before we finish. Now cosec of 3x squared. Now cosec goes to minus cosec cot. Okay, so I'm going to write minus cosec of the angle times cos of the angle, but then you times by the differential, but you're cosecing. That's the word, 6x. So you get minus 6x cosec of 3x squared cot of 3x squared. Now I actually think that YouTube automatically classified these videos as comedy, and I just think they just must know how funny I am. Number 8, x cot of 2x to finish off. Okay, so x cot of 2x. Right, this is a product rule. Okay, so u is x, v is cot 2x, and we get u dash is 1, and cot goes to minus cosec squared. Okay, so that goes to minus cosec squared of 2x, but times by 2. So uv dash plus vu dash, I get minus 2x cosec squared of 2x plus cot 2x, and that's my answer. Now we're ready now, guys, to do the hard ones: tangents, normals, stationary points. Okay, thank you.